A developer at Megacorp pasted a database password straight into an EC2 launch script. It felt harmless. But that one secret is now readable in every snapshot, every machine image, and by anyone who can open the console. One leaked credential, and the whole database is somebody else's. This is Cloud Architect Path from Stack Lessons. On with it. By the end of this video, you'll be able to look at any access control scenario and know exactly which identity to use, which policy type applies, and how Amazon Web Services decides yes or no. This is the front door to every resource on the platform, and the mental model here unlocks the entire design secure architecture's domain. One quick orientation before we begin. Identity is the foundation that everything else in Amazon Web Services security sits on top of, so it makes sense to start here. Get users, groups, and roles right, and a huge amount of the harder material later becomes straightforward. And policy evaluation, which sounds intimidating, is really just a small set of rules you can reason through step by step. That's exactly what we'll build up over the next few minutes. Let's pin down 5 terms you'll hear throughout this video. An IAM user is a permanent identity for one person or application, and it carries long-term credentials. An IAM role has no long-term credentials at all. It's assumed to get temporary, automatically rotated credentials for a session. An instance profile is a container that holds exactly one role, and it's what you actually attach to EC2. A resource-based policy is attached to a resource like an S3 bucket, and it names a principal who is allowed. And an explicit deny is a deny statement that overrides every allow. Hold on to that last one. It's the heart of everything. So what does IAM actually do? At its core, it controls who can do what, on which resource, and under which conditions. Now, back to Megacorp's problem. Their developers embedded database credentials straight into the application. The trouble is, once a secret sits in a launch script, every snapshot, every machine image, and anyone viewing the console can read it. That's the failure mode IAM is built to eliminate. It lets you grant precise, auditable permissions without ever storing a secret in the first place. Here's the one idea that unlocks this entire topic. Amazon Web Services is default deny. Nothing is permitted unless something explicitly grants it. And when a grant does exist, one more rule sits on top of it. An explicit deny always wins over any allow. Dip these two halves right, and every policy scenario becomes readable. Everything else in this video hangs off this rule. Picture IAM as a nightclub where the default answer is no. You don't get in unless your name is on the list. That name on the guest list is an explicit allow. It's what gets you through the door. But the bouncer also keeps a ban list, and that's an explicit deny. Here's the part that matters. The banned list always wins. Even if your name is also on the VIP list, the ban keeps you out. Allow gets you in. Deny overrides everything. 3 kinds of identity can act in your account, and the difference between them drives a lot of exam answers. On the left, the user is a permanent identity for one person or application, and it carries long-term credentials. In the middle, a group is a container of users. You attach one policy to it, and every user inside gets those permissions. On the right, a role is different in kind. It's an assumed identity with no long-term credentials, handing out temporary, rotating credentials only while a session lasts. Permanent versus assumed, that's the split to hold in your head. Here's something people get wrong constantly. A brand new IAM user cannot do a single thing. Not because you forgot a setting, but because that's the design. Default deny means nothing is trusted just for existing. The user has 0 permissions until you attach a policy that grants them. So if a scenario implies a fresh user can already act on resources, that's the wrong mental model. Identities start empty. Now, The group. The best way to think about a group is as a mailing list, not an org chart. It exists to send the same permissions memo to many users at once, that's all. And that framing kills a common mistake. You cannot put another group inside a group, so there's no nesting. You cannot put a role inside a group either, because groups hold only users. And because a group relates to permissions, not authentication, it can't be named as a principal, and it can't assume a role. If an answer choice tries to slip a role into a group, that's your red flag. And this isn't my interpretation, it's straight from the IAM documentation. The docs state plainly that user groups can't be nested, and they can contain only users, not other groups. So when you see a distractor that stacks groups inside groups, or drops a role into one, you can rule it out immediately. Groups hold users, full stop. Let's lock in what we have so far. First, default deny. Nothing is allowed unless a policy explicitly grants it. Second, users are permanent identities with long-term credentials, while roles are assumed and hand out temporary credentials. And third, groups hold users only, no nesting and no roles. Keep those three in your pocket, because the next piece builds directly on the role. If you remember one decision rule from this entire video, make it this one. When an application running on EC2 needs to reach S3, DynamoDB, or any other service, it always gets its permissions from an IAM role delivered through an instance profile, never from stored access keys. This is the canonical pattern for granting EC2 applications access to other Amazon Web Services, and understanding why makes every similar scenario straightforward. Let's see why. Stored access keys are like taping your house key under the doormat and never changing the lock. They're a long-lived secret sitting on the instance, readable in user data, environment variables, or config files. They have to be manually rotated, which in practice almost never happens. And when one leaks to a public repository, bots find it in minutes. The role, by contrast, is like a hotel keycard. Temporary credentials get delivered to the instance automatically, they're rotated for you, and no secret is ever stored. There's simply nothing to leak. That's why the role is the canonical, correct pattern. Now here's the piece that trips people up. You don't actually attach a role directly to EC2. Think of the role as an employee's job badge, with certain door access baked in. The instance profile is the lanyard you clip that badge into, so the EC2 machine can wear it. Start on the left with the EC2 instance, that's the employee. It reaches for the instance profile, the lanyard, which wraps around exactly one IAM role, the badge. So the thing you hand to EC2 is the profile, and inside it sits one role. That container is why the whole pattern works. This container detail explains a real headache. An instance profile holds exactly one role, though the same role can store it inside many profiles. When you create a role in the console, it quietly auto-creates a matching profile with the same name, so you never notice the wrapper exists. But the command line interface and the API do not do that for you. So if you build a role from the CLI and then go looking for it in the EC2 dropdown, it won't show up because there's no instance profile wrapping it yet. Make the profile by hand, add the role, and it appears. And Amazon Web Services is explicit about this in its own best practices guidance. When you're building on a compute service like EC2, Amazon Web Services delivers the temporary credentials of a role straight to that resource. So there's no need to distribute long-lived user credentials to workloads running on the platform. Read that as a direct instruction. For anything running on EC2, the answer is a role, and stored keys are the anti-pattern. Now that you know what identities are, let's talk about the policies you attach to them. There are 3 flavors of identity-based policy. On the left, an Amazon Web Services managed policy is built and maintained by Amazon Web Services. It's reusable and convenient, but you can't edit it, and it's usually broader than any one workload needs. In the middle, A customer-managed policy is one you build and control in your own account. It's reusable too, but you tune it exactly to your use case. This is your best path to least privilege. And on the right, an inline policy is embedded directly into a single identity. It's strictly one-to-one, and it's deleted the moment that identity is deleted. There's a second, deeper split you need where the policy attaches. An identity-based policy attaches to a user, group, or role, and it answers the question, what can this identity do? It has no principal element, because the identity holding it is implied. A resource-based policy is the other side of the coin. It attaches to a resource, like an S3 bucket, and it answers a different question, who is allowed on this resource? That means it must name a principal. Bucket policies and role trust policies are the classic examples. So here's a clean shortcut you can use on any policy you're shown. If you see a principal element, it's a resource-based policy. Identity-based policies never carry one because the identity is already implied by whatever the policy is attached to. That one element is the tell. Spot the principal and you instantly know which kind of policy you're looking at. Here's that tell in real JSON. Look at the principal line. It names a specific role in a specific account. That single element is what makes this a resource-based policy, most likely sitting on an S3 bucket. It's saying this role is allowed to call getObject on objects in the reports bucket. Notice there's no need to attach anything to the role itself. The resource is granting access from its own side. Another quick checkpoint. EC2 gets its access from a role wrapped in an instance profile and never from stored keys. Managed policies, whether Amazon Web Services owned or customer owned, are reusable across many identities, while an inline policy is strictly one-to-one and dies with its identity. And a principal element tells you the policy is resource-based. Now let's put it all together with the piece that ties the whole model, how Amazon Web Services actually decides. This is the evaluation chain, and it runs in a fixed order every single time. It starts at the top, where everything is denied by default. Then it asks the first question, is there any explicit deny that matches? If yes, the decision is deny, and it stops right there. Nothing downstream can save it. If there's no deny, it moves on and asks, is there an explicit allow? If yes, access is granted. And if it reaches the bottom with no allow at all, that's an implicit deny, and the answer is still no. Deny first, then allow, and default no. And here's that entire model in Amazon Web Services' own words. By default, all requests are implicitly denied, with the one exception of the account root user, which has full access. And then the line that decides so many policy questions, an explicit deny overrides an explicit allow. If you can recite just that sentence, you can reason your way through almost any policy scenario you encounter. It's worth separating two things that both end in a no, because the exam loves to blur them. An implicit deny just means no policy ever granted an allow. It's the absence of permission, the default state of everything. Add and allow, and the access flows. An explicit deny is completely different. It's a deliberate deny statement written into some policy, and no allow anywhere can override it. That's what makes it the tool for building unbreakable guardrails. Same outcome, very different power. So what happens when an identity policy and a resource policy both apply? Within the same account, they combine as a union, and allow either one is enough to grant access. Picture getting into a shared office building. You can get in with your own building pass, which is the identity policy. Or you can get in by being on the tenant's approved visitor list at the front desk, which is the resource policy. Either one opens the door. But if your name is on the do not admit sheet, an explicit deny, that overrides both and you're not getting in no matter how many lists say yes. That default deny starting point isn't just a rule, it's a design principle you should lean into. Least privilege means you begin from 0 permissions and add only what the workload genuinely needs. Nothing more. Why bother being that strict? Because scope limits the blast radius. If something does get compromised, tight permissions are the difference between a small incident and a catastrophe. And there's a famous case that shows exactly what happens when you skip this. In the Capital One breach, a server-side request forgery flaw let an attacker reach an EC2 instance's metadata service. From there, they stole the temporary credentials of an IAM role attached to that instance. Now, the role itself wasn't the problem, the over-permissioning was. That role could read far more S3 than it ever needed, more than 700 buckets worth. The attacker used those stolen credentials to sync it all out. The result was 106 million records exfiltrated. And the root cause wasn't a clever exploit, it was a role granted way more than its job required. One last identity deserves special care, the root user. Remember that exception in the Amazon Web Services quote? Root is the one identity not subject to default deny. It has full access to everything, always. That power is exactly why you lock it down. Turn on multi-factor authentication for root. Treat that as non-negotiable. Never create access keys for the root user, because a leaked root key hands over the entire account. And never use root for daily work. Create a separate admin identity and leave root untouched for the rare tasks that truly require it. Amazon Web Services puts this bluntly. They strongly recommend you do not create access keys for the root user, precisely because that user has full access to every service and resource in the account, including your billing information. There's almost no upside and enormous downside. Leave root with a strong password, multi-factor authentication, and no keys at all. Everything so far is the core model, and it's the foundation for what comes next. Roles get far more powerful once identities can be assumed across account boundaries. The Security Token Service, or STS, is what issues those temporary credentials and makes assumption work under the hood. And on top of individual account permissions, service control policies add guardrails across an entire organization. We'll go deep on all three in the next episode. For now, you've got the model that makes them make sense. Let's carry the essentials forward. Amazon Web Services is default deny, and an explicit deny always wins. Anything on EC2 gets its access from an IAM role via an instance profile, never from stored access keys. Groups hold users only, no nesting, no roles, and never a principal. A principal element is your signal that a policy is resource-based, and root stays locked down with multi-factor authentication on, no access keys, and no daily use. Now let's see how well all of that stuck with a quick 5-question quiz. Question 1. You create a brand new IAM user and drop them into a group. That group has no policies and neither does the user. Then, you try to add an existing role to the same group. What actually happens? Is it A, the user inherits default read-only access and the role joins fine? B, the user has 0 permissions and the role can't be added because groups hold only users? C, the user has full access until you restrict it and the role joins as a member? Or D, the user can do whatever the role allows now that it's in the group? Lock in your answer before I give it away. The answer is B. Amazon Web Services is default deny, so a user with no policy attached can do nothing at all. And groups contain only users, you can't add a role to a group, so that part of the attempt simply fails. Question 2. An application on an EC2 instance needs to read objects from an S3 bucket. Which approach follows best practice? A. Attach an IAM role to the instance through an instance profile. B. Save access keys in an environment variable on the instance. C. Store IAM user access keys in the instance's user data script. Or D. Embed the keys in the config file and rotate them monthly. Think about which option never stores a secret at all. The answer is A. An application on EC2 should always get its permissions from a role delivered through an instance profile. That gives you temporary auto-rotating credentials with nothing to leak. Every other option leaves a long-lived key sitting on the instance, and that's the anti-pattern. Question 3. You're reviewing a policy attached to an S3 bucket. It has effect, allow, action, get object, and a principal naming specific roles, ARN. What kind of policy is this? A. An inline identity-based policy on the role. B. An Amazon Web Services managed policy applied to the bucket. C. A resource-based policy identified by its principal element. Or D. A customer-managed identity-based policy. Run the tell we talked about before you answer. It has to be C, and here's why. The principal element is the dead giveaway of a resource-based policy. Identity-based policies, whether managed or inline, never carry a principal because the identity holding them is already implied. See a principal, think resource-based. Question 4. A user's identity policy grants get object on a bucket. But another policy that applies to the same request contains an explicit deny for get object on that same bucket. What's the final decision? A. Allow, because the allow and deny cancel out. B. Allow, because identity policies take priority. C. It depends on which was created most recently. Or D. Deny, because an explicit deny overrides any allow. Got your pick? Let's see. The right call here is D. An explicit deny in any policy that applies always wins over any allow. You can't outlaw deny. And note this is different from an implicit deny, which is just the absence of an allow. Only an explicit deny can override a grant that already exists. Question 5. Your security team is hardening the account root user. Which set of practices lines up with Amazon Web Services recommendations? A. Enable multi-factor authentication on root, create root access keys for automation, and use root daily for admin tasks. B. Enable multi-factor authentication on root. Do not create root access keys, and avoid using root for daily work. C. Disable multi-factor authentication to simplify login and rely on stored root keys. Or D. Delete the root user entirely and manage everything through IAM users. Pause here if you want more time. If you said B, well done. Amazon Web Services recommends turning on multi-factor authentication for root, never creating root access keys, and never using root for everyday tasks. Spin up a separate admin identity for that. And note you can't delete the root user, and it keeps full access by default, which is exactly why you lock it down. And we're done with IAM core, users, groups, roles, and policy evaluation. If this earned a spot in your study routine, hit subscribe so the rest of the Cloud Architect path finds you automatically. The comments are where I learn what's working. So tell me what landed and what didn't. Got a certification on your list I haven't covered yet? Drop it below. That's how the next course gets chosen. And if the style or the speed could be better for you, I genuinely want that feedback. Catch you next time.